Solve exactly. So what's different about this problem? What's different about this one? What's different? They don't have the same angle inside, do they? So how could, we need it all to be the same angle. What tools do we have that we could change one of those angles into the other? Right? Remember, we have the double angle formulas, right? They came from 5,5. And we have a way to go from a sine. The identity says the sine of 2u equals 2 sine u cosine u. What's important is that this 2u, right, is twice this angle. So if I go back to this here, I could use that formula on the sine of 4x, right? It'll be 2 sine 2x cosine 2x, because that'll cut that angle in half, right? Because that's what this does right here. It takes a 2u and it turns into a u. It turns it into half the angle it was before. So this I can write 2 sine 2x cosine 2x. That's using the double angle formula. And now I've got minus 2x minus sine of 2x. And then what could I do? You got a common factor of sine 2x, so factor it out. Sine of 2x times 2 cosine of 2x minus 1. Okay. What is the next step? What's the reason we factored? So that we could set them equal to 0 separately, right? We couldn't isolate the trig function here, but for each factor here, we'll be able to set it equal to 0, and then we can isolate. So this first one, if sine 2x equals 0, then remember, the one thing you cannot do, which you'll be severely penalized for, is to try to divide by 2. You can't do that. This one is actually not a 0 to 2 pi. This one you need a statement that goes plus n times something, right? So it's a little bit different than that. Okay. So remember, the way we do this is you say to yourself, where does sine equal 0? When you look at the unit circle, sine equals 0 where? 0 and pi and 2 pi. It actually repeats itself every pi, right? So we would write it like this. We would say when 2x equals 0 plus n times pi, then this thing sine 2x would equal 0. Divide by 2. X equals, and at that point you don't need to keep the 0. It's easy to say that's n times pi over 2. Right, so that's the part where you divide by 2, not up here. Right? I mean, the whole purpose of putting a multiple angle formula is to see how you handle that. If you don't handle that, then no credit. Don't divide by 2. Foot stomp. Don't divide by 2. Don't divide by 10. Okay. The next one, right? We got to do this one. 2 cosine 2x minus 1 equals 0. Cosine of 2x equals 1/2. Again, you look at the unit circle, you say, where does the cosine equal 1/2? We've actually used this already. What's the question? One thing at a time. Bob.
So if it was 2 sine 2x and factored out sine 2x, wouldn't there still be a sine 2x left? 2 sine 2x?
Where? Here? Going from here to here?
Yeah.
We factored out the sine 2x. What was left? 2 cosine 2x. There it is. Okay? Justice. Okay. So now we're back to where does the cosine equal 1/2? Pi over 3, 5 pi over 3, right? So you have to say when 2x equals pi over 3, but how often is that going to repeat itself, the pi over 3? I mean, I'm going to be back to the same place every 2 pi, right? So I have to say, when I'm doing this, I have to say plus n times 2 pi. That's how often it gets back to the angle of pi over 3. Okay, but now I've got to divide by 2. So x equals pi over 6 plus n times pi. And the same thing goes for the 5 pi over 3. When 2x equals 5 pi over 3 plus n times 2 pi, and then divide by 2.